take a look at some z-score work. So Kyle scores 447 points on an exam with a mean of 350, so we have our mean, and a standard deviation of 60. Find his standard score, or the z-score. And the z-score is commonly rounded to 2 decimal places. And we'll note that the units cancel, so the z-score is in fact a unitless quantity. So first off, we need to know the formula for the z-score. This is something that you might have memorized, but this will be provided on the formula for the exam. And this is z equals x minus mu divided by sigma. Now, as far as the x, mu, and sigma, we've already determined there's our sigma, there's our mu, and the real person's score, in this case Kyle's score, is the x value. So I'm going to follow through with the units so you can see that they reduce. And you will see the what was that? There we go. 447 points minus the mean, which is 350 points, divided by the standard deviation, 60 points. Now we reduce. The numerator we can subtract. That gives us 97 points. This is divided by the standard deviation of 60 points. And here we see that the points reduce. Therefore, the z-score is a unitless quantity. Let's work out the division. This is 97 divided by 60. And now, eventually, you have to stop this somewhere. And again, z-scores are commonly rounded to 2 decimal places. So if there's no rounding instructions, default to 2 decimal places for the z-score. That would be 1.616, 1.62. All right, let's take a look at the next one. Ellen scores a 37 on her exam. That is x. The mean is 20. That's mu. The standard deviation is 6. That's sigma. Find the z-score. So the z equals x minus mu over sigma. And this time they just said 37. I don't know if that's 37 points, or 37%, or whatever. So I'm just going to leave the units off, knowing that even if I included the units, they would reduce. 37 minus 20 over 6. And that is 2.83. Do a double check. 37 minus 20. Get that worked out. And divide by 6. There's our 2.83. Now, z-scores are comparable. The 447 points Kyle scored is not comparable to the 37 points Ellen scored. You would look at those and go, wow, Kyle is so much better. Look how many points he got. But if you look at the z-score, it tells you how you did compared to everyone else on the same exam. So 1.62, Kyle's z-score, it is positive. That means he is above the mean. That's good. But it's within 2 standard deviations, so he's still considered in the normal range. He scored above average but normal on the exam. Whereas Ellen scored a 2.83, also positive, also above average, but between 2 and 3 standard deviations. So she is outside of the normal range. Anything above 2 is outside the normal range for a z-score, for a population. So she has an extremely high average, or high score above average. She's more extremely above average than Kyle is. So even though Kyle had so many points, Ellen actually did better on her exam compared to how Kyle did on his exam. Interesting things you can do with z-scores. All right, go ahead and pause the video and work the problems out on the right. You should get the z-score of 2.18 and a z-score of negative 0.67. Positive z-score on the top. They're above average, bigger than 2. They're in the extreme category, but not too extreme, pretty close to 2. And then a negative z-score, they're below average, and still within -2 to 2, they're still in the normal range for this population, even though they're a little below average. Now, below average doesn't mean bad. Below average in weight might be good. Depends on what you're studying, whether below or above is preferred. All right, I hope this helps.